Welcome to another deep dive. Today we're going to be looking at some excerpts from the Gang of Four book, which is considered by many to be like the Bible of object-oriented software design.
Yeah.
We're going to be talking about design patterns. And, design patterns, I think, are a topic that come up all the time when people are talking about programming and software engineering.
Yeah, and there's a good reason for that.
And I think a lot of times people think that maybe design patterns are overly complicated or too abstract. And so what we're going to be doing in this deep dive is trying to break down these design patterns and the ideas in this book and make it more approachable and more understandable for everyone. So what are design patterns?
Well, they're essentially solutions to common problems that we see in software development.
Hmm.
And one thing I really like to emphasize is that they're not just these abstract ideas.
Mhm.
They're solutions that have been tried and tested in real-world applications over and over again. And that's why they become so valuable to software engineers. They provide us with a kind of shared vocabulary and a set of best practices that we can use to build better software.
It's like having a toolbox full of proven solutions.
Exactly. And like any good toolbox, you need to know which tool to use for the right job.
That's a great point.
One of the things the Gang of Four book does so well is categorize these patterns into three main groups: creational, structural, and behavioral. Each of these groups addresses a different aspect of software design. And just understanding these categories can really help you start to see the bigger picture of how design patterns fit into the overall process.
So it's not just about memorizing a bunch of patterns.
No, not at all. It's about understanding the underlying principles and being able to apply those principles to solve the specific problems you're facing in your own projects.
I like that. And I think that's something that we're going to try to really emphasize in this deep dive is that it's about understanding the why behind these patterns, not just the what.
Exactly.
So let's start with the first category, creational patterns. What are those all about?
Well, as the name suggests, creational patterns are all about dealing with the creation of objects in your software.
Hmm.
Now, you might think, well, creating an object is pretty straightforward, right? But as software systems become more complex,
Sure.
the way you create objects can have a big impact on the overall design of your application.
Okay.
Creational patterns provide us with different strategies for managing object creation in a way that's flexible, maintainable, and efficient.
So it's about more than just saying new object.
Right. It's about thinking about things like who should be responsible for creating the object? When should it be created? And how can we make sure that the creation process is adaptable to different situations?
Can you give me an example of a situation where a creational pattern might be useful?
Sure, imagine you're building a user interface.
Okay.
And you have different types of buttons. Regular buttons, radio buttons, checkboxes. And let's say you want to be able to easily add new types of buttons in the future.
Hmm.
A creational pattern like the abstract factory could be a great solution here. The abstract factory pattern provides a way to encapsulate the creation of families of related objects, like our buttons, without specifying their concrete classes.
So instead of hard coding the creation of each button type,
Right.
we could use the abstract factory to create them dynamically based on some configuration or user input.
Exactly. This makes our code much more flexible, because if we need to add a new button type, we just create a new concrete class for that button and plug it into our abstract factory.
Without having to modify a bunch of other parts of the code.
Exactly. And that's one of the key benefits of using design patterns.
There-
They help us create software that's more adaptable to change.
That makes a lot of sense. So abstract factory is one example of a creational pattern.
It is. And there are a number of other useful creational patterns, each with its own strengths and weaknesses. But they all share the common goal of providing flexible and maintainable ways to create objects.
Okay, I'm starting to get the picture. And it seems like understanding these creational patterns can really help us lay a solid foundation for our software designs.
Absolutely. The way you create objects has a ripple effect throughout your entire application.
Hmm.
So choosing the right creational pattern can make a big difference in the long run.
So we've talked about creational patterns. What about those other categories you mentioned, structural and behavioral? What do those have in store for us?
Well, we're just getting started, but those are stories for another part of our deep dive.
I can't wait to hear more. And for our listeners, be sure to join us for the next part of this deep dive where we'll explore those other fascinating categories of design patterns.
We'll be delving into structural and behavioral patterns, and you'll be amazed at how much more there is to discover in this incredible world of software design. So stay tuned, and we'll see you next time.
Until then, happy coding.
Happy coding.
So we left off talking about creational patterns.
Right.
And you mentioned there's two more categories that we're going to talk about.
Yeah.
And those were, I think, structural and
Behavioral.
behavioral. Okay.
Yeah.
So what, maybe let's start with structural. What are structural patterns all about?
So structural patterns are about how objects are composed or put together to form larger structures.
Mm.
They're about the relationships between objects and how those relationships can be used to create more complex and flexible systems.
Okay, so if creational patterns are about like creating the building blocks,
Yeah, like the bricks.
structural patterns are about kind of putting the bricks together.
Yeah, it's like the mortar and the way you arrange the bricks to build walls and arches and
I see.
stuff.
Okay, cool. Um, so can you give me an example of a structural pattern?
Yeah, let's talk about the adapter pattern.
Okay.
This is one that I think a lot of people can relate to because it's something we see in the real world all the time.
Okay.
Think about like a power adapter.
Hmm.
You travel to a different country and their outlets are different from yours.
Right.
You need an adapter to plug in your devices.
Sure.
The adapter pattern in software does something similar. It lets you take an object with one interface and make it work with another interface that it wasn't originally designed for.
So it's like a translator between two different parts of a system that don't speak the same language?
Yeah, exactly. It's like a diplomat smoothing over the differences between two countries
Hmm.
so they can work together peacefully.
I like that analogy.
Yeah, and one of the key benefits of the adapter pattern is that it allows you to reuse existing code without having to modify it directly.
Right. So if you have a library or a component that you want to use, but its interface doesn't quite match what you need,
Yeah,
you can use an adapter to bridge the gap.
exactly. Instead of rewriting a bunch of code, you just create an adapter that translates between the two interfaces. And that can save you a ton of time and effort.
And probably prevent a lot of bugs too.
Definitely. When you're modifying existing code, there's always the risk of introducing new problems.
Right.
The adapter pattern helps you minimize that risk.
Okay, so that's the adapter pattern.
Mm.
What are some other examples of structural patterns?
Well, there's the bridge pattern, which is kind of like a more sophisticated version of the adapter pattern.
Hmm.
It's used to decouple an abstraction from its implementation, allowing you to vary them independently.
Okay, that sounds a bit more abstract. Can you give me an example?
Sure, imagine you're building a drawing application.
Yep.
And you want to be able to support different types of shapes: circles, squares, triangles. The bridge pattern would let you separate the concept of a shape from the specific way it's drawn.
Hmm.
So you could have a shape class that defines the common properties of all shapes, and then you could have separate implementation classes for each type of shape, like circle, square, triangle.
Okay, I see.
And these implementation classes could be swapped out easily without affecting the shape class itself.
So if I wanted to add a new shape, like a pentagon, I could just create a new implementation class for pentagon.
Exactly. And you wouldn't have to modify any of the existing code that uses the shape class.
That's really powerful. It seems like these structural patterns are all about creating systems that are more flexible and adaptable.
They are. They help us avoid those rigid, monolithic designs that are so difficult to change and maintain.
Okay, so we've covered structural patterns.
Yeah.
What about behavioral patterns? What makes them different?
So behavioral patterns are all about how objects communicate and interact with each other.
Hmm.
They focus on the flow of control and responsibility between objects, and they provide us with ways to manage complex behavior in a more organized and efficient way.
Okay, I think I'm starting to see the distinction here. So creational patterns are about creating objects.
Yep.
Structural patterns are about how those objects are put together.
Like the architecture of the system.
And behavioral patterns are about how those objects behave and interact with each other.
Exactly. It's like the difference between designing a building, constructing it, and then figuring out how people are going to use it.
That's a great way to think about it. So can you give me an example of a behavioral pattern?
Sure. Let's talk about the observer pattern.
Okay.
This is one of my favorites because it's so versatile and widely applicable.
What does it do?
Well, the observer pattern defines a one-to-many dependency between objects. So you have one object, called the subject, that maintains a list of its dependents, called observers.
Okay.
And whenever the state of the subject changes, it notifies all of its observers, and they can then react to that change.
So it's like a broadcast system.
Yeah, exactly. It's like a news channel sending out updates to its subscribers.
I see. So, for example, if I had a stock market application
Right.
and I wanted to be notified whenever the price of a particular stock changed,
Yeah.
I could use the observer pattern to do that.
Absolutely. The stock price would be the subject, and you would be an observer. Whenever the stock price changes, the subject would notify you, and you could then update your portfolio or whatever else you need to do.
That's really cool. It seems like the observer pattern could be used in a lot of different situations.
It can. It's used in everything from user interfaces to event handling to database systems.
Wow. I'm starting to see how powerful these behavioral patterns can be.
They are. They provide us with a whole new set of tools for managing complex behavior in our software.
Okay, so we've talked about creational patterns, structural patterns, and behavioral patterns. Is that all of them?
Well, those are the three main categories. But within each category, there are a bunch of different patterns, each with its own specific purpose and implementation.
It's like a whole universe of patterns.
It is, and the more you learn about them, the more you start to see how they can be combined and applied to create truly elegant and sophisticated software designs.
I'm feeling a little overwhelmed, but in a good way. It's like my mind is expanding to take it all in.
I know what you mean. When I first started learning about design patterns, it felt like a whole new world was opening up to me.
Yeah, it's like I've been given a secret decoder ring for understanding software.
That's a great way to put it. And the best part is that we've only just scratched the surface. There's so much more to explore in this deep dive.
I can't wait to see what else we discover. And for our listeners, stay tuned for the next part of this deep dive, where we'll delve even deeper into the fascinating world of design patterns. Okay, so we've talked about all these different types of patterns,
Yeah.
but how do they actually affect the software development process? Like, what are the benefits of using them?
Well, one of the biggest benefits is improved code reusability. When you start using design patterns, you'll find yourself writing less code from scratch because you're reusing these proven solutions.
Hmm. So it's like having a library of building blocks.
Exactly. Instead of reinventing the wheel every time you encounter a common problem, you can just grab the appropriate pattern from your toolbox. And that saves you a lot of time and effort in the long run.
That makes sense. And it probably leads to more consistent code as well.
Definitely. When you're using established patterns, your code tends to be more structured and predictable, which makes it easier for others to understand and maintain.
Right, because if I'm looking at some code and I see a pattern I recognize,
Oh,
I can
yeah?
immediately get a sense of what it's doing.
Exactly. It's like speaking a common language. Design patterns provide a shared vocabulary for developers,
Hmm.
which can really improve communication and collaboration within a team.
Okay, so we've got reusability, we've got maintainability. What other benefits are there?
Well, design patterns can also make your software more flexible and adaptable to change
Yeah.
because they often promote loose coupling between objects.
Hmm. What does that mean?
It means that the different parts of your system are less dependent on each other.
So if I need to make a change in one part of the system,
Right.
it's less likely to break other parts of the system.
Exactly. And that can be a huge advantage when you're dealing with complex software that's constantly evolving.
I see. So it's like having shock absorbers in your code.
Uh-huh. Yeah. I like that
It
analogy.
helps to cushion the impact of changes.
Exactly. And that can make a big difference in the long-term maintainability of your software.
So it seems like design patterns are not just about writing better code, but also about improving the overall software development process.
Absolutely. They're about creating software that's easier to understand, maintain, and adapt to change.
Okay, my mind is officially blown.
Yeah.
This deep dive has been an incredible journey.
Yeah, it's been fun.
It's really opened my eyes to the power and elegance of design patterns.
I'm glad to hear that. And I hope it's inspired you to learn more and start incorporating these patterns into your own work.
It definitely has. And for our listeners, I encourage you to explore the world of design patterns. You might be surprised at how much they can enhance your understanding of software design and development.
And remember, design patterns are not just abstract concepts. They're practical tools that can help you solve real-world problems.
So don't be afraid to experiment and see how they can work for you.
Exactly. Have fun with it.
Until next time, happy coding.
Happy coding.